Hello guys, welcome to Backbencher Studies channel. In the last video, we discussed how we can comment about the stability of the closed loop system based on the location of poles and the characteristic equation without actually finding out the actual roots of the characteristic equation. So by using Routh-Hurwitz criteria, so in this tutorial we are going to learn another problem of Routh-Hurwitz criteria, in which we will be having a special case in which we have a zero in the first row of right array. So this is a case 2 which is called as epsilon method. So let us quickly solve this problem. So determine the stability of the system with this characteristic equation over here, given over here. This is a fifth order characteristic equation. So let us make the Routh array by filling the coefficients. So we have s power 5 and s power 4 and s cube and s square and s power 1 and s power 0 in the Routh array. And eh, just next to s power 5 we have 1 and alternatively 2 and 11 in as the Routh array. So this is how we can fill the Routh array 1, 2 and 11 in the Routh array. And next, as for force coefficients 2, 4 and 10 in this Routh array as well. So let us calculate the next elements in this Routh array. So 2 into 2, that will yield 4, minus 4 into 1, that will be 0. 0 by 2 will become 0 over here. So we are having 0 in the first row. Then what we can do is we can substitute a small value epsilon in place of this 0. And by placing this small value epsilon which is tending to 0, we can actually comment about the stability of the system. So so by removing 0, and if we place epsilon over here, then that would be a great idea. And next, if we calculate this 6, how we can got that? So 2 into 11, that will be 22, minus 10 into 1, that will be 22, minus 10 will be 12, and 12 by 2 will be 6 over here. And we don't have any coefficients over here, so we have 0 over here. So we have a what we have done is, if we are encountering a 0 in the first row of this Routh array, we are taking out that 0 and we are replacing that with a small positive number epsilon. So that's, and moving on to next session, we have the next coefficients of s square over here. So 4 into epsilon, that will be 4 epsilon, minus 6 into 2, that will be 12. 4 epsilon minus 12 by epsilon, the coefficient will be minus 12 by epsilon over here. So that would be 4 minus 12 by epsilon over here, this coefficient. And if we kind of find out this coefficient which is over here, 10 into epsilon, that would be 10 epsilon, minus 0 by epsilon, that would be 10 over here. So if we fill the next row of this Routh array, that would be C1, which is the 4 epsilon minus 12 by epsilon over here. So I'm sorry, it is wrongly written over here, that there will be 4. So and 10, and we have 0 over here. Moving on to next row in this Routh array, we have C1 into 6 minus 10 epsilon by C1, which is the coefficient over here, which is a coefficient in terms of epsilon square, that we can find out just like that. So this is how, if we substitute all of these, then we have the D1 coefficient over here, which is a function of C1 and epsilon. If we substitute C1 in this also, we can have the function in terms of epsilon square as well. And if we find out this coefficient over here, that would be d1 into 10 minus c1 into 0. That would be d1 10 into d1 by d1 over here. So that will result into 10 over here. So what we have to do is we replaced this with a small positive number epsilon. So if this epsilon is tending to 0, then how these values are changing, based on that we can determine the rows of this first column. So these are the rows of actual rows of the Routh array, first row, first column of this Routh array. So minus 12 by epsilon and 6 and 10. So if we substitute epsilon is 0 in this expression, we are getting 6 over here. So, and if we see this, then this one will yield actually, this one is actually a negative number which is yielding in this. So if we see for number of sign changes, we have no sign change and no sign change. And here we have one sign change because it is plus and it is minus. So it is we are having one sign change, and from here to here there is a sign change also because it is negative and it is positive. So we have two sign changes in first row, first column of this Routh array. So the number of roots in right half plane of this characteristic equation is equal to 2, thereby saying we have the system is unstable because there are two sign changes in the first column of this Routh array. So this is how we can comment on stability of the system. If we are encountering a zero value in the first row, we replace that with epsilon. That's all for today, guys. Thank you for watching this amazing session.